Hello everyone, hope you all are doing well. So I'm back with another Leetcode Daily Challenge and it is Leetcode number 662, maximum width of binary tree. It is a medium level question and I also feel the same. So the question is you are given the root of a binary tree, return the maximum width of the given tree. Okay. So the maximum width of a tree is the maximum width amongst all level. The width of one level is defined as the length between end nodes. Okay, means the leftmost and the rightmost uh, non null nodes. Okay, where the null nodes between the end are also counted into the length calculation. Okay, so it is guaranteed that the answer will be in the range of 32-bit signed integer. So here you can see that uh, for this example the answer is 4. How it is 5 3, and here you have to count 1 because it is given that if the null node is between your start and end node, so you have to count it. Okay, otherwise you need not to count it. So I have so they counted it and 4. Okay, you can see here 5 3 null 9. Okay. Similarly, if you see this example, here the answer is 2 because it is 5 3, and for this it is null and null null. So this all are on the outside our given start and end node. So it is 2. Okay. Here it is again 2, and the constant are the number of nodes in the tree is in range of 1 to 3000, and not dot one be from minus 100 to 100. Okay. So let me take an example for you. Let's take this first example. Let's say it is 1, 2, 3, 4, 5. Okay, it is 6. And here it is nothing. So I am putting an 1x. Okay. So the first foremost approach is you need to find the maximum width for every level, and you need to maximize it. So it is simple. You can get an intuition like it is a BFS. Okay, or a BFS, or you can say level order traversal. Okay, now I am going to use a approach called heap. Okay, like heapify type of thing, like heap uh, kind of thing to keep track of the length. Okay, how what I will do, I will initially take this node. Okay, means say I take this node and it is 1, so I have taken it as 0. Okay, let's say it is 0, or we can say that it is x. Okay, its number is x, so its left child will be 2x. Okay, 2 into x. Okay, so and its right child will be 2 into x plus 1. Okay, so if I represent this in a okay, so here is a optional thing, like in heap we do like 2 into x plus 1, and here 2 into x plus 2. So you can take this also, or you can take this also. Okay, both of these are correct, but however for I will take this example. Okay, 2x plus 1 and 2x plus 2 for the right side. So what it is representing now, like if it is if in the heap all the elements are in array. Okay, sort of array thing. So it indexes, like if it is x, let's say x is 0, for currently it is 0, it is 1 2. So it represent like my next child. Okay, this is the node 1. My left child will be at 2x plus 1. So here x is the indexes. Okay, so it is 2 0, which is 0 plus 1, it is 1. So my 2 will come here. Now it is 2x plus 2 for the right child, so it is 2 into 0 is 0 plus 2, it will be 2. So my next element is at second index, so it is 3. Okay, so so you have to do the same thing for this also, this also. Okay, so this is the step for the heap. However, we need not to keep track this all elements. Okay, like where which element is present. We only need to keep track of every level, and when we process that level, we need not to keep track of that element. Okay, so for that only I have taken something. I have taken the queue of data type. I will take a queue, okay, of course, of data type, pair of this is tree node type, okay, for keeping the nodes against my integer, which will keep the track of this x. Okay, I will keep this thing. Now initially it will be you can start from 0, but when I have started it from 0, so I will take this x as 0. Okay, so and you push it into the queue as simple as we just need to do the simple bfs. Okay, then I will, when I am when I will push my left child. Okay, so I just do the same thing, 2x plus 1, and when I put my right child, I will do 2x plus 2. Okay, so and then I will check if my current the difference between this value and this value is what, and if it is greater than my current value, max value, I will simply update it. Okay, so this is the complete approach. Okay, so let me show you the code for better understanding. Okay, so here I have taken out if not root, then simply written 0. Then I just put my first element, first node inside with. Okay, so here I have taken the long, but here it is given that it is guaranteed that the answer will be in the range of 32-bit. However, I have tried it, but it gave me a runtime error, so I changed it to long. Okay, so I just simply put it down, and I just take a max size element. Initially it is as 0, then I perform a simple bfs. I take out the size. Okay, and I iterate through the size, and before that I just keep track of my queue front element and queue last element. Okay, and it's means its value. Okay, if it is my queue, okay, and if there are two elements present in the queue. Okay, so I just take the first element index and the last element in last element value, so we get the difference of this and this to maximize it. Okay, I hope you understand it. And I just calculate the max size, then I iterate through the queue, simple bfs. Okay, then I just take out my front element, and I remove that element from the queue. And here one more thing to notice is that as we are doing a heap kind of thing. Okay, like heap, as I told you, it is a heap representation. Okay, when you do this, it is a heap representation, so it may exceed your means here the constant are bit high for heapify, so it may exit the long. Okay, so again I have tried to remove this code, but it is give me a runtime error. Even long is not able to store this thing. Okay, so what I have done is, as I have told you, when once we process a level, we need not to take care of that, like keep track of that. Okay, so I just do the I just do my front element minus the start element. So how it will help? For example, if if uh, if it is if its index is 4. Okay, then what will be its index? Like this index, it will be 2 into x plus 1. Okay, so it will be 2 into 4, which is 8. 8 plus 1 is 9. So you can see that it can grow means 2 times. Okay, so if my value is something like 10 to the power 10, so it will goes to 10 to the power or I can say, if it is 10 to the, okay, yeah, 10 to it will go 10 to the power 20. Okay, which is not able to store in a long. That's why I just, what I have done is, I just reduce my size. Okay, so what I will do, I will take this one. Okay, means this current one, Okay, then I just minus it from my start. Start is stored here, okay, from the left and right, so that my range get reduced. Okay, so I hope you understand. Like here it will minus by 4, so it will be 2 into 4 minus 4 will be 0 plus 1, which will be again 1. Okay, so my range get reduced from 1 to, okay, x. Okay, not x, let's say it is n. Okay, depends here how many node is there. Okay, so that's why I just take this one, and I just simply perform the pp5 method, my left and right, push it down, and I just updated my values, and again it will call in the loop again and again and again, and after a point the queue gets empty, and you get a maximum size. Okay, so I just simply return it. Okay, so here two thing to take care. If you are following this method, you have to take this long, and you have to reduce this. Okay, so let me submit the code. As you can see here, I have tried many time and it gives me runtime errors. Okay, so it is accepted. So hope you understand this video, and I will provide the code in the description.